Hi, good morning. Jesse's going to be a difficult one to follow. Thanks for a great talk. I'm going to talk a little bit about what I call the HOE stack, which is Helm plus OpenNMS plus Elasticsearch. For those of you who don't know, or those of you watching at home, my name is Jeff Gehlbach. I am the Director of Applied Innovation for the OpenNMS group. I've been messing around with SNMP since 2000. I've been contributing to the OpenNMS project since 2005 when I started in through the community. And I've been working for the OpenNMS group since about the end of 2007, which is, sometimes I wake up and think, wow. Anyway, what I'm here to talk about today is a sort of demi stack that we can build using, as I said, Helm, which is our Grafana plugin bundle, OpenNMS, which is, of course, our network management platform, and Elasticsearch, which all the kids love, and everybody knows what that is anyway. We've got a little bit of an agenda here, so we'll do our best to follow this. And I'm going to talk a bit about really mostly a real-world case study from a project that I did for a customer in 2017. So those of you who have been following along with some of the shiny new technologies like that David Smith talked about yesterday with the new clustering engine and that Jesse was talking about with Kafka, some of those things were not available during this real-world deployment. So if they had been, I think things would have been a little bit different in a couple of ways. But anyway, let's talk a little bit about the history of event management in OpenNMS, just to get a start here. So once upon a time, 16th century Bavaria, some dude was working a field with a hoe. Things were much simpler in those days. This guy didn't have to worry about reduction keys or topics or temporal clustering or any of those things. He didn't have to know what a Drools engine is, or he didn't know what a UEI was even. But eventually we had to know what a UEI is. So OpenNMS came around and it had events. Who remembers when the UI looked like this? Nobody? I know I do. Yeah. Yeah, some do find it a simpler time. Nostalgia. So as a review for those who don't remember, events were originally actually acknowledgeable entities in OpenNMS, so they were not always thought of as being immutable. It was originally possible to go in and acknowledge an event in the event list. It's actually still possible to acknowledge events, just we don't show the controls to do it, and you should never do it because it's totally deprecated. If you need lifecycle, you should be using alarms instead, right? Alarms were conceived as a sort of notion of events that matter. And yeah, they can stand for multiple different events. They're reduced using a reduction key. And I got a typo in my slide there. I'll fix that later. Yeah, basic deduplication was done just via the reduction key. There were some limitations to this original implementation. One of these is that external events, those being ones that came in as SNMP traps or syslogs or even via the TCP transport, had to be transported all the way to the OpenNMS server where you had your listener running. There was no minion. If you had overlapping IP address ranges, you had to do disgusting things with NAT and similar technologies, and it was really bad. So that was a problem. Also, in the original alarms implementation, correlation functionality was limited to the single reduction key. So we've come a long way from there in the past few years. We've added things like Drools and the newer clustered engine technologies that will be out in a release coming at you soon. Also, the only place we could put events and alarms was into the relational Postgres database, which is fine because that's where we put everything, right? But as we'll see, there are some limitations associated with that. It's not necessarily the best place to put tons and tons and tons of events. Automations were limited to SQL-based trigger action event tuples. That's still largely the case for automations, but in the upcoming Horizon 23 release, we're actually doing a revamp of that. So things have changed a little bit in that department too. We also notably lacked any kind of supportable API for getting events and alarms out of the system. So if you were an external tool that needed access to those things, guess what? You go digging in the database for that stuff. Not exactly ideal, but you know, it was a simpler time, right? We also had a really bad alarm browser and a really bad event browser in the OpenNMS web UI. They haven't gotten a ton better. Little incremental improvements around the edges of those, but frankly, they're still pretty bad. Not really appropriate for a shop that's used to using something a little more enterprisey. But yeah, we've come a long way. We've advanced in our technology a little bit, and now we're doing things at a bigger scale, and someday we'll look back on this and say it was a simpler time back in 2018. Where we have come a long way here, a couple of ways. External events can now come in via minion. So if you have inconvenient network topology, you can just put minions out into the backwaters of your network and use those things to transport your traps, your syslogs, your other external events into the center of OpenNMS, which is great. Yeah, if your network topology isn't fantastic or was designed by somebody else, then sometimes you can work around that with minion. We've also added drools, which I mentioned a moment ago, to improve the correlation possibilities, and we're adding this clustering engine, so that's coming a long way too. The ability to do advanced correlation, machine learning, and all that kind of fun stuff right in OpenNMS is really going to change things a lot. We can also now stream our events and alarms to an external platform like Elasticsearch, which is a big win because that means we don't necessarily have to hold on to as many events for as long in the relational database, which is not designed to store those. We've also got a REST API for getting events and alarms out of the system, so it's now much easier to write external tools that get these things out of there, and the drivers for that have been Compass and Helm, which is our Grafana application. And those give you access not only to events and alarms, but to all of the resources in the system and a plethora of other things, basically the whole object model of OpenNMS. We also added, in addition to the performance data source, which everybody I think is probably familiar with for Grafana, a faults data source for the Helm application in Grafana. Has anybody used the faults data source yet? A few of you? Good. You like it? Yep. Excellent. Good. Glad to hear it. So here's a little bit of what that looks like. Certainly looks a lot nicer than the alarm browser built into the OpenNMS web app, don't you think? This uses the alarms REST API, of course, and it provides a new panel control for Grafana, which is called Alarm Table. And it supports some alarm actions. So it's not just a viewing browser. You can also interact with the alarms in the system via right-click actions. So you can acknowledge an alarm that's not been acknowledged yet. You can unacknowledge an acknowledged alarm. You can escalate or clear an alarm. And you can edit the alarm memos, the sticky and journal memos on an alarm right from the Grafana console. And then we also have the notion of custom actions, which are super cool. And this is, I did the best I could with this slide. The contrast down here is really, really poor. But suffice it to say, what I've done here is I've just set up a custom right-click action in the alarm table for Helm that says, if an alarm that you're looking at has a parameter called issue identifier, then add a custom action called Jira lookup to the right-click menu for that alarm. And when that is clicked on, take the user to the URL that's specified here. Has anybody used this functionality yet? It's kind of hidden. Not a lot of people know about it. It's pretty cool. You can do virtually anything with it that you can do with a click-across integration. Sometimes you need a little bit of glue in the form of a cheesy CGI or something on the other side, but you can do a great deal of neat stuff with it.
Is that a Git?
Yeah, it just turns it into a hyperlink. So the user clicks in, and it's as if the user clicked at an hrefs anchor in the browser. So yeah, it doesn't support fancy XML HTTP request or anything like that. You have to handle that stuff in the middle if you want it. So we've come a long way. We've done a lot of really cool stuff. The fact is, though, this stuff is not getting simpler anytime soon. It's only getting bigger and bigger and bigger. There's only more and more grain to harvest, if you will. More and more weeds to kill, too. Data volumes are growing. Has anybody seen data volumes go down at any sites recently? Didn't think so. Yeah, we're seeing in a typical event-focused customer environment that the event volume is only ever increasing. We're seeing hundreds, thousands of events per second in some environments, and that can present a real challenge. Putting all those events in the relational database, not a great way to play when you're talking about really high event volumes. When the indexes on the event table get a little bit wonky, database performance crawls, right? That makes all of OpenNMS crawl. So sticking events into the events table of the relational database is not a solution. We cannot be a data warehouse and an operational database at the same time. We see plenty of other products on the market. The one that comes to mind for me is Netcool, which uses an in-memory database to solve this problem, right? The whole thing's always in memory at all times. You don't have to worry about IOPS, and it's wicked fast. But we don't really have that luxury. We're tied to Postgres pretty strongly because of our architecture, and so we have to find other ways to work around this problem. But the fact is also, customers want to be able to analyze and audit their historical events. They need to have a place to put them so that they can go back through that history. So how do we handle this without sacrificing performance? So here's where I actually jump into the case study here. This is a real customer environment, as I said, that I worked in 2017. They are a popular provider of in-flight Wi-Fi internet access. There are a few of those, so I'm not giving away the game here. And their workflow for managing the in-flight systems is 100% SNMP trap driven. Every flight, when it takes off and reaches cruising altitude, the airborne system in the plane sends a hello trap. And that means, okay, this flight has started. So there are some varbinds in the trap that tell us information about like which aircraft it is, what the flight number is, which carrier is operating it, those sorts of things. In between the hello trap and the goodbye trap, which it sends when it drops below service altitude, we can get lots of other different traps. Some of those carry metrics for performance data, which this customer doesn't actually do anything with. Some of them carry information about faults that might happen in the airborne system, and so on. And we also get a heartbeat trap every 5 minutes, although that's a little bit variable depending on factors. This customer's legacy event management platform is Netcool Omnibus. So they have a single multi-threaded trap deprobe sitting in a physical colo. They've also got a single object server. I think those two are actually on the same physical hardware, not sure. And they're using Impact to approximate something like a state machine. So they're basically saying, okay, flight starts, stuff happens, flight ends. They're modeling all of that in Impact, which is the Netcool advanced correlation platform. The awful thing, the worst thing that can possibly happen to ruin the staff's day at this company is what they call a dark flight. That's a flight where no service is available for whatever reason. So we never got a hello trap when we reached service altitude. We never got any heartbeat traps in between. We never got a goodbye trap. That means they didn't make any money on that flight. Really bad for revenue, and the first priority for this team is to recognize when this happens so that we can do something about it. Now, we do have some technical constraints, and I'll talk more about these, but the number one weird technical constraint is that anything that flies on a civil aircraft is subject to extremely strict regulation from the civil aviation authorities. I'll talk a little bit about the actual costs of this, but just keep in mind, we can't just say, well, I don't know, fix it on the thing that's flying on the plane, because that's impractical. So here's what the front end looks like. Shift operators are used to the netcool active events list. Anybody familiar with that one? Yep. They want something that looks more or less like that. The shift managers need the ability to audit the history of each alarm, so they need to be able to look back through and see which shift operators took which actions against which alarms at what time. And then the internal customers also need to be able to report on months worth of historic events. So there's our event storage requirement. More technical restraints. This customer was also in the middle of an IT transformation, so they were facing a mandate to move everything to AWS. They also had a pretty inflexible set of requirements technically, as far as like which DevOps pipeline they were allowed to use and some other factors. Of course, the pipeline that they were mandated to use was probably the worst possible fit for deploying OpenNMS, and also probably the hardest one to set up a reproduction of in a lab. So that didn't help in this case, but we managed. Another fun constraint is that the airborne systems have a hard-coded IPv4 address in them. Can't change it. That IPv4 address is where all the traps go. Can't add a second one, can't change it to something else. Sorry, we're stuck with that. It would take months of time and hundreds of thousands of dollars in costs to make that kind of a change. The traps ultimately do hit that MT-TRAPD server, probe on the probe server. They go through a load balancer in the physical data center to get there. And also fun, you can't do any ground to air traffic. That is a no-no for whatever reason. Could change in the future, I was told, but yeah, nope. You can't ping the aircraft, you can't do SNMP polling for data collection, you can't do anything in the other direction. You're strictly receiving traps and driving something like a state machine with them. So, we got a ton of grain. How are we going to eat it? Let's break down the problem a little bit into a few facets here. So, deployment. In this case, we put a minion on a VMware VM in the physical data center. This was the little bit of the solution that was going to be allowed to continue living in the physical data center, mainly because of that hard-coded IP address that all of the airborne systems are sending their traps to. The rest just had to be done, deployed via the pipeline, which was made up of EC2 for compute, RDS for a stand-in for the Postgres database. We actually ended up using Aurora in the end for better performance and flexibility, and SQS, Simple Queuing Service, which I think we've talked about a little bit already. That's Amazon's message broker. Configuration file mutability, as Ronnie pointed out in his Hello Ground talk yesterday, is a big problem when you're deploying in a DevOpsy way, even when it's not containerized, because every time you need to make any change to OpenNMS's configuration in this environment, you can't just SSHN. In fact, in prod, you're not allowed to have root at this customer's AWS environment. So even if you wanted to change something in prod because everything is on fire, sorry. What you do is you go and you make the change to the configuration and you do a git push, and the pipeline runs and it tears down the old OpenNMS and brings up a new one in its place. That's how it has to be. So watch out for that config file mutability. Trap intake and correlation. We actually got in a remarkably long way down the road just using event-conf.xml. It was a pretty onerous process translating the MT-trapd rules that this customer is using into event-conf.xml, but it got us most of the way there. We got the rest of the way using a combination of rules and a third-party thing that they were already using for some other stuff that they liked and we're happy to continue using. I think if we were doing this today, we probably could have done everything we need to do using the clustering engine that's coming up in the next release. But in this case, they opted to do it a little bit differently. All right, here's we get to the E part. We are archiving our events to Elasticsearch. Yay! These guys are using the elastic.co AWS hosted Elasticsearch as a service option. Worked great with that. They could have run their own Elasticsearch, of course. They could have used Amazon's Elasticsearch as a service offering in AWS. They chose to use the one that elastic.co provides. In order to get there as far as event performance and keeping OpenNMS running smoothly, they implemented some extremely aggressive event cleanup automations in vacuumd. The time to live event for any given event was measured in hours, in some cases in minutes. I think the heartbeat traps got cleaned up multiple times per hour, just in order to keep the indexes clean, keep everything rolling along smoothly, and avoid a performance drag. All right. Now, here is the Helm part, alarm visualization for the operators. Yeah, we used the Helm faults data source plugin with the alarm table control. I already showed you a little bit of the eye candy about that. I think the custom action stuff was actually custom development that Ben did specifically to meet this customer's requirement for it. And they ended up doing a number of interesting things with it, including integrating with a trouble ticketing system. They use ServiceNow for their trouble ticketing. So we managed to reverse engineer how you can create just a get that pre-populates the form to create a ticket, and that was perfectly sufficient for their needs. So we ended up not building a full-fledged ServiceNow trouble ticketer for them. I ended up building most of that at DevJam this year instead. So all good. And then finally, the alarm reporting and analysis piece of this. They're using the Grafana Elasticsearch data source plugin to do a lot of their alarm reporting and event history reporting. And what they can't do with that, they're doing with Kibana. So just basically using the Elastic tools that are available for those purposes whenever we can't make it work with the HOE stack. So I have an answer to how you can consume a ton of grain. Change its form. Integrate it. So here's how we made all of this work together. I've got a bit of a block diagram of the thing. So you can see here we've got this in the cloud, and then we've got this other cloud down here, right? So we've got traps coming into a load balancer in the colocation facility. Those are getting load balance between two minions. It's actually an availability group here. So whichever minion is available to take the trap will receive it. We're going to SQS here instead of ActiveMQ, which is the standard deployment way of running minion with its message broker. So we also did the SQS implementation for this customer. So if you're running OpenNMS in AWS, you can substitute SQS for ActiveMQ. That works. It also works for RPC as well. So you can do data collection and traps both via SQS. So we substituted in SQS for ActiveMQ. That was work that we actually did as custom development for this customer. We're also using RDS Aurora for the relational database. It's 100% Postgres compatible. Worked really well. It's a little bit spendy, but actually Aurora is less so than classical RDS. We're running OpenNMS on EC2 on a really, really big, I don't remember what the image size designator is, but we had to do a considerable amount of proving to get approval for the size image that we needed for the event volume that these guys are doing. We've got Helm and Grafana talking to OpenNMS, and of course to Elasticsearch for the historical reporting. We're outboarding our events and our alarms into Elasticsearch as well, and SQS tying everything together here. So that's the quick block diagram. Component version requirements, you're going to want to use Helm 2 and Grafana 5. Helm 2 requires Grafana 5, so that's your thing. You're going to need Horizon 21 at least, Meridian 2017 at least. If you can use newer, you should. Horizon 22 is probably going to perform much better than 21. And Elasticsearch 5. If you can get your hands on Elasticsearch 6, that's all the better. But 5 will work fine, just for events and alarms. So sometimes after you have your integrated grain, you can end up with, I learned a new word, a katsunyama. And we did have a few of these, so I thought I would call out a few of them. We did early on field the alarm change notifier plugin, which some of you have used, I think. And we learned pretty soon that when you're dealing with large event volumes, as I mentioned yesterday, that thing gets to be a little bit problematic just because of the way that it's implemented. It creates a bottleneck in event D. So we had to kick that out. A further headache that we had was we found that once this plugin is installed and the system is running and processing events, uninstalling it is pretty much impossible because it's a bottleneck and it needs to destroy all of the triggers that it created in order to unload the feature, and it can't destroy the triggers as long as the triggers are in use. So we basically had to destroy the instance, ask the DBA to go into the Aurora instance and remove all of the triggers from the database schema, and then we were actually able to uninstall the feature. So I would say if you're in a high event volume environment and you're thinking of using that plugin, don't field it too readily in your prod environment because you could get stuck with it for a while. Also, another finding we had was that back pressure from Elasticsearch on event D via Alarmd was causing bottlenecks. This took us a long time to diagnose. Jesse and I spent a long time on a hangout trying to get to the bottom of this thing, looking at thread dumps and the like. Finally, I think the ultimate solution was Jesse made Alarmd multi-threaded, so you don't have to think about that so much anymore. And also from that, we learned that undersizing your Elasticsearch cluster really makes the problem worse than it already was. So don't be cheap when you're sizing your Elasticsearch cluster. Another thing, don't be cheap when you're sizing your Aurora instance. That's also really, really bad for performance. And having some ammo for your sizing needs is a good thing. There is a little bit of variability in the versions of things that you're going to want to use. I think I covered most of this already, but I wanted to call it out in its own slides. This one is important, and I didn't mention it before. Horizon 22 versus Horizon 21 reworks the way we do event and alarm forwarding via the REST API to Elasticsearch. It's sort of been integrated together with the Kafka producer. So it works differently. The admin guide has coverage of those changes. So if you look at the admin guide for Horizon 22, it'll explain what's different to doing it with Horizon 21 if you've found a guide that refers to that. For events and alarms alone, again, Elasticsearch is fine, but if you go to Elasticsearch 6, you'll also be able to support flows if that's something you're interested in. So you should just go for Elasticsearch 6 if it's within your reach. And also already said this, but Helm 2 requires Grafana 5. All right, so this is the part where I conclude. I think this HOE stack thing is actually a pretty cool way to deal with high event volume environments. And it's also a fun name. And I think all of my pictures are just of garden implements. So mission accomplished. Anybody got questions about this? I'm happy to answer as many as you've got. I've got plenty of time. Craig.
Problem with the fire may basically caused by feeding events back into event B.
Okay, I'll repeat the question. Were the problems with the alarm change notifier plugin caused by feeding events back into event D? That was one of the problems. The other problem was the way it implements itself with the use of database triggers. It kind of breaks the layering that we've got in place for those things, and it also leads to the scenario I talked about where once you've loaded it and you're processing enough events for it to cause a bottleneck, it's pretty impossible to unload. So I think it's a very useful plugin in low volume environments, but I think its design needs a little bit of work. I know it's your baby, and
Not worried about that. I mean, it's great feedback. I just wondered whether the problem is in the triggers in the database, in which case it's a database problem, or it's a problem with the actual interface of OpenNMS.
yeah, I would have to go back and look, probably discuss with Jesse and look at some of the notes that I took during this project to answer that with certainty. If you want to talk about it afterwards, we absolutely can. Sure. Anybody else? Okay. Thank you very much for your attention.